Here we look at organic chemistry. Organic chemistry is the chemistry of carbon. It's sometimes called carbon hydrogen chemistry. Now, carbon, number 6 on the table, and carbon appears pure as graphite. The one on your pencil, and a diamond, the one on the ring or weddings, and other good things. Now, the difference in graphite and diamond being pure carbon comes with the electron distribution. We set carbon as 6, the mass number is 12. It has 6 electrons. There's 6 protons and 6 neutrons. Now, we will have it on the first shell, on the second shell, we have 2 electrons in the first shell there. We have 2 electrons here as well, opposite spin. We have 1 electron there, that makes a 5. That makes that 6. Now these electrons here are on the p. So we have 4 on the outermost shell, the valence electrons is 4. What happens is that this atom will gain energy and S shall be excited. When excited, this electron here will come there. Now, we had pure S here, P there. Now an S has gone to P, that constitutes sp3 hybridization. Hybridization. That's sp hybrid here. And that's where you find your diamond. And sp2 hybridization, that's a graphite. Now, with that electron has moved there, we can remove the electron there. We can remove the electron there because it is already moved up there. That's the electron there. Now, this arrangement here has a potential of accommodating 1, 2, 3, 4 to make up those 4 pairs. Now, that's why when you have carbon, it appears there. Now, if we put, if that is from a hydrogen, that from a hydrogen as well, that from the hydrogen, that from the hydrogen, this compound here is called methane. Now, carbon can only go to a maximum of 4 bonds here, as it's shown up there. Now this falls under a family called alkanes. These are fuels or simple paraffin. This is a simple paraffin. The most famous alkane is octane, which is petrol. The mechanical gas. Now from here, this being the first, but we have to know the properties of alkanes. Properties of alkanes. One is that they have a single bond. It's called single sigma bond. Two is saturated. Three, it has a general formula CN H2N plus 2 there. The fourth one is that it undergoes substitution reactions. Substitution reactions. Now, let's go to, now you see that this is a single bond here, single bond here, single bond there. This is a single bond called sigma bond. It's a single bond. Now saturated. We go up there, we realize that carbon can only take 4. This carbon here has taken 4. It can't take anything more than 4, so it's saturated. Can't take anything more. Now let's come to the general formula here. I hope you appreciate that carbon here is 1. So this is 1 here. This becomes 2 times 1 because N is 1. 2 times 1 is 2 plus a 2 makes up 4 hydrogens. These are 4 hydrogens. Satisfy that general equation. Now, because it's saturated, you can't add anything. It better takes this one out and get another one. What will happen at 4, e.g. at 4, is that I'll have that. There's been hydrogen there. The hydrogen there. Let's say plus chlorine there. This will give us a carbon there. And then I can put the chlorine there. Another one here. The hydrogen there, hydrogen there. Plus H2 here. Now, you realize that this chlorine here substitute that hydrogen there, this chlorine here, substitute that hydrogen. That's what it means. Now let's go to the one that is 2 carbons. This one is called the ethane. And the other one, we have 3. Please be careful, each and every carbon there has 4 bonds. Now, this is C3, H is 2 by 3 plus a 2, which is C3, 2 times 3 is 6 plus H, 6 plus 2 is 8. That's the formula for propane. This one is called propane. And what is the other carbon there? Keep on adding one carbon. And then this one is called butane. Now, I hope you realize that each and every one of these compounds end up with A and E because they are from the alkanes. The homologous group is called alkanes. So these are the members of that group. The one that follows here will be pentane with 5 carbons, hexane with 6 carbon, heptane with 7, and octane, the petrol that you use, with 8 carbons. 8 carbon, octa for 8, these are 7 carbons. These are 6 carbons. On the long chain is 5 carbons. On the parent chain there. Now let's have a look at another homologous group called pentene. Another homologous group called alkene. We have to look at the properties of alkene. Properties of the alkenes. 1, they have a double bond, 1 sigma, 1 pi bond, 1 sigma, 1 pi. They are unsaturated. They adhere to this formula, CnH2n. And because they are unsaturated, they undergo addition reaction. Because they are unsaturated, you can still take something in. The simplest one of this compound, of this group of compound, is that I have hydrogen there, hydrogen here, hydrogen here. Carbons are 2, 2 times 2 is a 4, so 4 hydrogens. And this is called ethene. Look at that. Look at that. The next one, we have 3 carbons there. Now let's look at this carbon here. 1, 2, 3, 4 bonds, and this one here is 1, 2, 3, 4. 1, 2, 3, 4. So put the hydrogen there, hydrogen here, hydrogen there, hydrogen there, hydrogen there, hydrogen there. This alkene with 3 carbons is called propene. The next one will have 4. And this will call butene. The next one is going to be pentene. Pentene, hexene, and so forth. Let's once more go and have a look at another homologous group called alkynes. Let's look at the properties. One, they have a triple bond. One, sigma 2 pi bonds. Two, they're just very unsaturated. Three, they have this general formula. Two n minus 2. Because they are by nature very unsaturated, they undergo addition reaction. They undergo addition reaction. And the simplest of that will be a triple bond. Then you can put your carbon here. Now this carbon here has 1, 2, 3, 4 bonds. This carbon here, 1, 2, 3, 4. We agree that maximum is 4. And then this is called fine. And then we'll go to 3. Or we can put it here. And then that will be hydrogen there. That will be hydrogen there. Hydrogen there. Hydrogen there. Hydrogen there. As let's look at the formula here. we have 3 of carbons. 2 times 3 is 6. 6 minus 2 is a 4. That's the first hydrogen, the second, the third, and the fourth. That has that formula. And then this kind of a compound is called pin. And then we go to hydrogen there, hydrogen there, hydrogen here, hydrogen there, hydrogen here, hydrogen there. Now this is called butene. Right. Now let's go to another group. This group is called alkanols. Or alcohols. Now, alcohols they have a functional group and the functional group of the alcohol is OH. Now, if you have carbon there and then OH there, hydrogen there, this is methanol. It's an alcohol. And the second one in that group will be ethanol. And the third will be propanol. That OH can be on any carbon here, but that will make it to have a particular name. But here, just call it propanol. We will come to the naming of compounds later, called nomenclature. Naming of compounds at the later stage. And then, as a propanol, you can have 4 C's for butanol. 1, 2, 3, 4, 6. That makes up butanol. Let's go and have a look at the other group. The other group is called organic acids. Or called carboxylic acid. Carboxylic acids. Now, functional group of the organic acids. COOH. Functional group COOH. Now we have this one here. We have OH there. And we have an O here. Therefore, we will have an H here. Let's have an H there. And then 1, 2, 3, 4, 5. Must get rid of this one here. Because carbon has only 4, maximum of 4 bonds. Because that's what we have. And then this is called methanoic acid. That is methanoic acid. The second one will be ethanoic acid. 2 C's there. Hydrogen there. And then this one is called ethanoic acid. And the next one will be propanoic acid. And now, this must be one again here. We put in the hydrogens there. This is called propanoic acid. And the next one will be butanoic acid. Let's go to that. COOH. The functional group makes it possible for you to identify the compound The functional group makes it possible for you to identify the compound as to which homologous group it belongs. Then this one here will be butanoic acid. That's butanoic acid. Let's go and have a look at another group. Called esters. Now, ester comes from an organic acid, carboxylic acid, plus an alcohol, and then you remove water molecule. Now, let's see what happens here. If you have a carboxylic acid, this one here, plus an alcohol, just write it this way. Now this alcohol here is propanol. And then this one here is ethanoic acid. Now, look at the removal of water. I've removed H2O. Now what remains there will be C, and what you see remaining here is an O. Hydrogen there, hydrogen there. We forgot to put the hydrogens up there. So hydrogen there. And then this is an ester. And this is called propyl ethanoate. Propyl ethanoate. Now this is the name and the surname. The name comes from the alcohol. The name is derived from an alcohol and the surname is derived from an acid organic acid as ethanoic. So the surname is ethanoid. These are esters used in flavoring drinks like this bottled water. You have banana flavor, peach flavor. You have your soaps, margarines, your roll-ons, your Q-Tags, all those are esters with that good aroma. We'll have a tutorial on this, or we'll have to put more. We have aldehydes, ketones as two more homologous groups which you can put here, and then we can therefore have a tutorial. I hope you understand this.